Okay, well, what I've set up here is the tenders, uh, wheels, the trucks that we have come together with in the last year or two, and several versions. Let me show you a complete set here. This is a tender, it's a little elongated. These are sintered metal instead of brass, but I can do brass. These are 6-wheel pickup. And these 4 wheels here are wired. This wheel set is not wired. I have a method, I just haven't put it in yet. So these 4 wheels are hot. This is one track, this is the other side, and the power comes up to a AC, comes up to a DC converter, and then it goes down. Here would be the motor controller, and then out here would be volt regulators, and then this would go out to the engine. And reason I came up with these, as you know, on the real engines, we had these 2 wheels would pick up that track and these 2 wheels would pick up that track, and that was it. And if you had a little dirt or something in the way, you weren't going to get a good power. Lights will flicker, the engine might stall, you give it a nudge, or you rock the tender and it takes off in the opposite direction, you know, all kinds of things would go on. So, and when I started putting digital stuff, especially sound, I really needed to have consistent power from the track up into the electronics. So I started coming up with techniques and ways to get the power out of the track. So this is one of the earlier designs, and there's a little hole there. We'd put some wire in, the wire would rub on the axles, and the axle wheels were separated by a piece of plastic. Here you can see, we call that the axle spacer. These are axles that are cut in half. They're half the width, and inside there is a little piece of plastic, so when you push the axles into that spacer, they can't touch. So this guy can have positive or outside rail, this guy can have negative or the inside rail, and they won't conduct, but they can conduct up. So all I had to do is take the power from the axle and then bring it up in through a wire. So that's what these, there's a groove there for the wire and a hole for the screw, and they would fit and rub. This was an idea I had for making them wired at the bearing where I could press in, and it worked, but the problem was, how do I route 4 wires instead of just 2? And as you can see, it starts to get just a little messy, and hadn't really taken that very far. The components, one of the things I had to recognize was I was fitting into American Flyer, and their tenders had an opening that was the design, size, and shape. This one is not exactly accurate because it's not powered. This is for a caboose, but the opening inside here was a opening for a bushing that would isolate the truck from the chassis, so the chassis wasn't hot. The trucks carried the power up and was insulated. So I would use that dimension to size the opening inside the tender. And I would start with pieces like this, pretty typical. Some of them I would have a boss on the bottom side to mimic the ones on the train, but I found that I didn't need that. I actually put the boss on top of the truck, so it would sit like this, and everything would clear and it would go. This is one design for Royal Blue, I believe. Yeah, RB, Royal Blue. There it is. You can see it's one of my test units. I got a little solder iron close to it. But the trucks would fit in just like this, up under here. And then I would have what I call a pivot pin, and it would push down inside this hole. Some of these sizes have changed, and some they haven't. Let me try this side, see if it's any friendlier. No, okay. Anyway, they do. The ones I use fit. I got them all standardized now. This one hasn't been standardized. Okay, that's always fun. Let's try this one. Oh God, this is gonna be worse. Yep. No, it's not. There it is. Okay, there you go. So you can see here, the pivot pin is free to pivot inside that plastic, and it pivots very slow, little pressure, it's not gonna wear. And then this guy would fit in here like this, and this is the threaded insert for the either the connector or a coupler. And this would sit on here just like this, and you would put a screw in the bottom, a shouldered screw, and this would have a threaded insert. It would fit in here. You tighten that up, and this would pivot under here, and it just would mimic the shape of the flyer stuff. And then when it was in place, okay, so we'll do it again. Do this one this time. Do this one this time. And what would happen is you would actually end up with some kind of a suspension kind of. Wheel came off. That's okay. I just threw this together for this. You could actually rotate this on the pivot point, and if you had a bump in the track or the track was uneven, this could actually handle that and would go around, and it wouldn't, the wheel wouldn't lift out and that kind of thing. So that all worked out nice. The original side plate that I had, I tried to mimic the one that was on the tenders at the time, and there would be a cover here. This is an old unit that popped off, doesn't matter. But you can see here was the threaded insert, and here was the pivot pin for the axle, so the axle would fit in here like this, and that was bronze. So you just put a little piece of oil, a little drop of oil in there, and you were ready to go. And I actually, in this earlier one here, I had some brass wire, and I wound what looked like a coil spring, and I would fit it in here and glue it in from the backside. So it would look like a brass coil spring on this particular unit. And I did that for a few engines, but it was pretty time consuming, so I kind of stopped, and I then went to this idea of molding in. Well, when I went to the 3-wheel, the challenge was the pivot was now in between the two, and there was nothing there. If I tried to do it here, you can see there was nothing there. So I just molded the spring in on one side so that I would have room to put the threaded insert without coming out. It's pretty interesting. So anyway, I did this with the molded spring, so it looks like it had suspension that way, and that seemed to work. I did it in black so you can see a little more realistically how it would work. Did I put these in upside down? Oh my God, what a fool. Yeah, no, yeah, I don't remember. Yeah, they're upside down. I don't know what's wrong with me. All right, need more coffee. At any rate, that's the black one. These are red. Red's usually for prototype. Black is when I'm getting close to production. This was used on an engine, or one like it. So as I got closer and closer to the end here, I've made some adjustments. There's a red in this, and you can see these are identical, fairly identical. But for argument's sake, I'm going to show you here. When I put these get glued together. The reason I split them separate is they have a nice flat surface, and I can get all this detail printed out in nice detail, and then I just flip them over and super glue them together, and they work out great. But if I put these side by side, I'm hoping you can see, this one is lower than this one, which means it's going to pull the tender up to the bottom of it's going to fit tighter up to the chassis, and that's what I needed to do on this particular engine for Leon. And also, it's wide. It's a little wider. This may be one of the later ones that's already wide, but earlier ones you can see they're a little thinner and not as wide. So I made it a little thicker and a little wider just to give it a little more beef, and then I shortened it up, and this then will hold these units here. And I made this change. Oops. Now see, I made these in two pieces. This is the inside and this is the outside. So when you see the outside here, you'll recognize it from the Hudson and the Northern side frame, I call it. And it is hard to really see because the finish is so, it's a 3D printed part. If you spray paint or whatnot, it'll look very, very similar to the unit. So these guys get pressed to the center, and the holes all lined up. I just cut it in two so I could print it. You glue that together. This becomes the frame. Then this there would be a threaded insert there, and this would bolt in like this. So that's how that would work. That's what I'm going to build today, and I'm going to assemble this on a new chassis. This is for a new tender, actually. We had a design contest and Leon won. And so I wanted red on the inside and black on the outside, so I just split it down the middle. That gives me the details all get done in detail, and then the interface is very smooth, and this came out just fine, so it works out great as far as the placement. So these are the details. They're like this. Okay. Then the pivot would slide through this opening. These haven't been cleared. They have a little extra plastic in them sometimes, so I got to push that out of the way. Okay. Then I can bring it over here and put this on top now, like that. And then I can shove this through maybe. There we go. So that'll help in the alignment, and that's how that's going to work. And then this piece is going to sit here. It's going to sit here like this and pivot. This will get glued to it, and then these side frames will get bolted to that. Bada boom. So that's what he's going to get by the end of today. This will be all assembled and wired and ready to go. That's what I'm going to do today, and I'm going to show you. I won't show you it. I'll just do it and then come back and show you. How's that? But that's what's going on, and the whole reason why we had to do this was we have a new tender body. I had asked Leon to put one together for me that could be used in an Atlantic or a Pacific and would give us a little more room for the electronics that we talk about. We have to have room for, right? So these are the electronics that would fit in here, and that he's done. This is for the royal blue, so I needed something about the royal blue size, and that's what this is. I'm also going to be turning this into 3D print, print the sides, fuse the corners, and we'll have a 3D printed tender as well, and that will fit onto this chassis. It'll be designed to fit into this chassis, and this goes on like this. There's a little overhang at one end. What? How can that be? I'm losing my mind. This must be it. Yeah, this is it. This goes on here like that. Oh, backwards. There we go. Now we're cooking. This goes on here like that. That goes on like that. It bolts in. I had to screw in earlier. And then the pivots come down, and the wires will go feed in, and this will be the new design. Oh, I know what this is for. This is for his real. Yeah, I apologize. This is for this new Atlantic Pacific. This one was for not this tender, but another tender around here somewhere. It's his custom engine. Sorry about that. Okay, well, that's what I'm up to. That's how that would work. This is the royal blue tender. This is the prototype. You know it's because it's red. It also has slots for the tabs, so the tabs can go down. And then this was what we would use here. And it appeared that the 6-wheel were just a little too big to be put on here because they start to get crowded. They get a little crowded when you put them together. See that? I don't know. So these may get stuck with the old 2-wheel. We don't know. We'll just see how it works. We can mix and match, not a problem. Put them what we want. And that's what I'm going to do today. I just wanted to give you an idea of what goes on. These are the inserts. These are the brass pieces. And the brass pieces fit into these areas here for the bushing. They just press in. And in this case, they actually help me with the alignment because they fit with the other half of the truck frame. The other half then would fit where they are, and you push them together, and you put some epoxy in there, and you glue them in, and then you got it. And then we we use heat when we put this in so that it's a nice snug fit and it doesn't distort anything. You get it hot with a soldering iron and just push it in until it's flush, and that's your mounting surface. So that's that, and that's how these get put together, and they'll be glued and all that, and then this becomes a side frame. It's very stiff, you can see that. That's what we're going to be doing. I'm going to build all this up and put them on his tender, and it'll be fine. You'll see. All right, that's it. Later.